Hello, and welcome to this video on malt. Malt, specifically light malt, has been mentioned in previous videos, so it is time to explain what malt is and why it should be of interest to the home brewer. Malt is germinated cereal grains that have been dried in a process known as malting. The grains are soaked and allowed to germinate as would normally occur in seed growth. However, it is halted by drying with hot air. This develops enzymes that convert starch into glucose among other saccharides. It also increases the amount of proteases. It is then cooked until the desired coloration and as a result caramelization is achieved. This is also known as the Maillard reaction. This is very much like the process described in making sake. Malting can be applied to various grains: malted barley, maltose, and malted rice. Malt is used in beer, whiskey, and vinegar production. The most common grain used is barley. The process of malting begins when grain is received at the malt house from the farm. It is taken in from the field and cleaned, otherwise known as dressing, and dried to remove moisture. This ensures grain is kept in the best condition possible to produce malt. As an example, barley is tested to check for suitability and to prevent dead or unfit grains from entering the process. Some of the checks used are grain moisture, nitrogen content, foreign matter, fungal growth, germinative capacity, germinative energy, and water sensitivity. After the grains are typed and sorted, it is shunted into the drying process. Drying begins as barley is received at the malt house. It begins with a moisture content of more than 13% and must be dried before it can be safely stored. This will ensure that germinative capacity is retained. The moisture is removed by circulating heated air up to 50 degrees throughout the building. This can be performed using dedicated grain facilities or as a batch process using a kiln. High temperatures or over-drying will damage or kill the barley in this time, and the grain will not be able to germinate after steeping. The dry barley can be safely stored for up to 18 months without fungal growth or loss of vigor. After drying the grain to ensure it is suitable for storage, it is then cleaned. The aim of barley cleaning is to remove foreign matter. For example, straw, chaff, or dust. These can be found in the incoming grain, and only leaving the grain will produce a better quality malt. Magnets remove anything that is metallic. This in turn reduces the possibility of sparks. This could lead to a dust explosion, which is a considerable risk and cause of danger within a silo for grain. Rotating and shaking is used to remove unwanted foreign matter, particularly large matter such as straw, and smaller matter such as sand. During the sieving process, an aspiration system removes the dust. The dust is the most significant risk, as it can cause explosions more than anything else. Shaking screens are used to separate small stones, and the machinery then uses the clean barley and then exits at the bottom. Half the corns are separated, and these can be used to remove broken kernels. Half kernels need to be removed, as only one half will germinate and produce enzymes, which wastes half of the possible stored material, which wastes time, resources, and money for a company. At the end of the process, the grain is weighed, and this determines how much waste has been generated. It's then transferred to a silo for storage. Storage is the next stage, and our example grain of barley must be safely stored to maintain the grain vigor and safety of the food. Storage at a malt house is normally done in a vertical silo made of steel or concrete. This is simply due to ease of use. Large amounts of grain are normally stored in these facilities, and the grain is stored in a manner that protects it from moisture and pests. Typical silos will store between 5,000 and 20,000 tons of clean, dry barley ready for malting. During storage, the temperature of the silo is measured and monitored over time, as the temperature increase can indicate insect activity or mold growth. Additional equipment may be used to keep the grain temperature below 18 degrees centigrade to inhibit insect growth. Silos are normally fitted with a system for rotating the grain from one silo to another. This minimizes heat generation and, as a result, minimizes the possibility of fire. Fumigation may also be used to administer a fumigant, which will prevent any fungal growth. Inappropriate storage of the grain can lead to one of fire, loss of food, lack of food safety, or considerable financial penalties when the loss of resources occurs. The next stage is the wetting process. The wet process begins with steeping to get germination started, and it ends with kilning, which removes moisture and produces a stable product. A batch of malt is known as a piece, and these can be as large as 400 tons at a time. Steeping in effect recreates the events of spring. Steeping is the start of the active malting process, and water is added to cover the grain, and grain moisture content rises from 12 to 40 to 45%. In modern systems, And in the modern malthouse, the grain is submerged in wet and then drained and then put through the same cycle 2 to 3 more times. This achieves the highest rate of moisture penetration, and as a result, the grain moisture content hits its highest possible count. Wet standing is when the grain is immersed in water. It is known as a wet stand. Air is then pushed through this slurry of water and grain. The aim of this is to create aeration. The aeration increases the amount of moisture and increases the grain's access to the moisture. This increases and maximizes the growth of an example grain like barley. Other advantages of this are to increase the amount of mixing, to remove dirt, and even out any hydrostatic pressures, which have been mentioned in previous videos with regards to osmotic pressure on yeast. This moves pressure from the bottom to the top of the vessel and equals it out. An airflow rate that is quite high, in the tens of cubic meters per hour, is used. Air resting or dry standing follows this, and at the end of the wet stand, the water is drained out, and this is the start of the air rest. During this point, fans are used to supply fresh oxygen and to remove CO2 produced by grain respiration. The temperature of the air supply is important, as too high or too low would significantly alter the ability of the grain to activate both enzymes and to also operate in its normal conditions. This is normally in the range of 10 to 15 degrees centigrade. The aeration requirement of meters per second is significantly higher in this stage than it is at the earlier stages due to higher metabolic activity. At the end of this steeping stage, the grain is cast out to germinate. This can be done as a slurry or as a moist grain during the air resting stage. In order to recreate the gene and cellular activity of the grain in spring, it is necessary to allow germination to occur. The aim of germination is to grow the necessary grains into a partial seed. This allows the development of malt enzymes. These modify the structure of the barley. They break down the cell wall and the protein matrix. This allows access to starch. Germination produces a large amount of heat, and this means precautions are necessary, especially in light of the earlier statements regarding the ability of the dust cloud to explode. Enzymes produced during germination are needed to break down the starch, and for the brewer, distiller, or in this case the home brewer, it is important for the mashing process. The grain bed is maintained at a constant temperature between 10 and 16 degrees. This ensures metabolic activity occurs, but is not so low as to be inefficient, but not so high as to damage any of the enzymes in use. The constant supply of fresh air and humidified air ensures the turnover of the enzymes and the turnover of the starch is constant. At this stage, the malting house has effectively reproduced spring. Now it needs to be stopped. This is done by kilning. Kilning reduces the grain moisture content and stops germination. In the first stage, which is known as the free drying stage, the air temperatures are kept cool, and this dries the grain without causing damage to the enzymes. As the grains dry, the air temperature is increased. This is in the second stage, or the forced drying stage, and this further forces drying of the grain until the target malt moisture is reached. This is approximately 5% by weight, or 1/3 of the very initial grain moisture content. During forced drying, the relative humidity of the air is dropped, and this allows the air to draw off extra moisture on top of what has already been done through heat. During the last few hours of kilning, the air is raised to above 80 degrees centigrade. This breaks down the variety of proteases and enzymes used to both break down the structure of the grain and the starch into saccharides. This reduces the potential amount of malt thereafter, but ensures there's no off flavor. The high temperature kilning also produces color, and as stated, this is something called the Maillard reaction. Finally, the kilned malt is cooled before the kiln is stripped or emptied. This ensures that no further changes occur beyond what is designed. So far, the malt house has successfully recreated the process of spring, encouraged growth, and then stopped it. Unfortunately, as with most plants, in this case grains, there is a rootlet that is grown out of the top of the grain. The next process addresses that problem and is called deculming. The rootlets of the malt, also known as culms, are removed. As soon as it is removed from the kiln, the removed culms are normally sold as animal feed, as they are both a sugar-rich substance and relatively simple to get rid of. The clean malt is then stored in silos, and it is blended with similar malt pieces, and this produces a homogeneous batch of malt, something incredibly desirable in a mass-produced industrial product, especially if you're discussing the topics of beer production. After all of these processes, there are a variety of undesired byproducts in the malting process, and this is addressed through malt cleaning. The malt is cleaned prior to sale using sieves and aspiration to remove any dust, lumps, and stones. Magnets are again used, and also further milling to remove any particularly obvious burnt or undesired products of the malting process. At the end of the entire process, there are several kinds of malt generated, and these will be described in detail in another video. But in short, they are pale ale malt, wheat malt, and rye malt. These are then further divided by the malting process, degree, and roasting used. In summary, malting is a transformative process to create more sugar from a starch-rich source, which can then be used to sweeten and add flavor in a complex way to beverages and brewing. Thank you for watching this video. Please post any comments, questions, or suggestions below.